Hello. In this video lesson, we're going to talk about the third unit of HP Statistics, which is gathering data. In this unit, we're going to be discussing designing experiments and surveys, the different sampling methods, and randomness and simulations. Firstly, we're going to talk about census. Census is just the complete list of the entire population. It just means having all the possible people that in a given population. However, there are some issues with these. For example, it can be very expensive to get a census, or it is very difficult to get all the people. So it's difficult to get all the people, all the population. Sometimes, for example, if you went on a door-to-door basis and you try to count the number of people in the household, if you did that, for example, sometimes there'd be people that aren't at home when you're doing your survey. Next, we're going to talk about is population, which is just the entire collection of people we want to learn from. So it's just everyone that we want to study their behaviors. The next is a sample, which is just a proportion of the population that is representative of the entire population. So for example, if I had the population of a school and if I picked 10 people and I say these 10 people are representative of the entire school, I would say this is my sample. The next one is a sample survey, which just uses the sample to determine characteristics of a population. Uh, Something that a lot of students forget is that size is always better than percentage. So I'll put that in bold. Remember, size is better than percentage. That means that if you had a population of 10 people and you picked out nine of them as your sample, even though that's a 90%, it's far better to pick a population of 100 and pick 50 people. Size is always better than percentage because you can get a larger spread. The next is an experiment, which is just a controlled study where treatment is provided. Controlled experiments can often or can always show a cause effect relationship. What do I mean by control? Control just means that given everything else to be constant, like there's nothing variable between different participants in the study. An observational study. It is just where researchers observe the participants. Unlike an experiment, no treatment is applied, which just means that the researchers will just observe how members of the study react to different stimulus. The next two are two types of studies which we call retrospective and prospective. So retrospective is just something where past behaviors are studied, and prospective is where future outcomes are studied. So for example, retrospective could be taking a group of 20 smokers to see how smoking has impacted their lungs, whereas prospective could be taking 20 people right now and telling them to smoke one cigarette a day to figure out what happens to their lungs over time. Four things are key in the principle of experimental design. We have control, randomize, replicate, and block. So for control, what does it mean by control? It just means to control lurking variables. As I mentioned in the last video, lurking variables are variables that are not directly part of the experiment or simulation, but could have an impact on the outcome. Randomize just means to randomize treatments to the subjects. So I can't forcibly say that person A will get treatment A. I have to randomly assign it. If it comes out that way, it comes out that way, but it has to be randomly assigned. Replicate doesn't mean do the study multiple times, but rather means replicate or do it multiple times with multiple subjects or participants. So I need to do it with a large spread of people. And finally, block. Blocking just helps reduce the effect, reduce the effect of lurking variables. So blocking just helps reduce certain effects that could be caused from lurking variables. The next thing we're going to talk about is blinding. If an individual in the experiment doesn't know what treatment they're getting, we consider that being blinding. Now there are two types of blinding, single blind and double blind. Single blind means where either the experimenter or subject doesn't know which treatment. So it could mean that they are, for example, the experimenter doesn't know who's getting what treatment, but the subjects do, or the subjects don't know what treatment, but the experimenters do. It's double blind, which is where both the experimenter and subject don't know which treatment is being applied. So neither one of them knows which one, but there's a third party that is applying these treatments to understand the effects. Sometimes these blindings can help control personal preferences. So for example, if I blindly gave smokers half of them an actual drug versus a drug that acts like the actual drug but is actually a fake, this can help reduce personal bias. Let's talk about the types of sampling. First of all, we have something called a simple random sample. It is just a sample in which participants are chosen randomly and have an equal chance of being picked. Now this section is very important. Randomly and have an equal chance of being picked. There is no bias towards a certain participant or a bias against a certain participant. Everyone has the same chance of being picked. If there are 20 people, each person has a 1 in 20 chance of being picked. Now how do we conduct a sample in this? First of all, you have to figure out what your target is, which means what are you trying to accomplish in this sample? What is your end goal? The next one is figure out how you're collecting data. So you could use a random number generator or a table of values. So when we do get to simulations, we will discuss how this happens. The next one is you need to set a start and end point. At what number do you start and at what number do you end? If, for example, you have a simulation to try and find the first 5 occurrences of a heads, then once you reach 5 heads, you will stop, and when you start with 0 heads, you will start. The next one is describing how you're looking for your target value. Means if you have a simulation, are you looking at digits 2 digits at a time? Are you looking at it from left to right? Again, when we get to simulations, this will be a lot clearer. And lastly, as all good sampling, you have to conclude. What did your simulation or your sample tell you about the population? The next one is systematic sampling, which is just placing the sample in an order. So for example, you place them by name alphabetically or by height or by weight. In this situation, you will choose every nth thing or person. So if I line them up by weight and I said 2, I'll pick every second person in the thing. So if, let's say I lined them up by weight. So first guy's weight of 10, 20, 30, 40. I would pick the second person and then the fourth person. Stratified sampling is just grouping the sample based on something that is similar characteristics, which we call a strata. From here on, you just do an SRS. A lot of people will forget what SRS means, but they just need to remember that it's a simple random sample. After you figure out what you're characterizing them on, you just have to do your SRS. Cluster sampling is very similar again to stratified. It is basing them off different characteristics, and then from there you do an SRS. Now, if I had a class, everyone's taking AP statistics, and I say that the people who are sitting in the first row are one group because they are all teenagers, that'll be a stratified sampling. But if I just randomly pick a cluster, so I say the person in the 5th, 7th, 12th, and 14th seat, they are one group, that would be cluster sampling. Multi-stage sampling is very simple. It is just an SRS followed by a follow-up. So for example, in some situations, SRS doesn't lead to the best outcome. Sometimes people don't respond to your sample. Then you just ask a follow-up question. Like for example, if you didn't respond to the survey, why? Few are going to be a few less common but still very important vocabulary. First, we have blocking, which is just separating the sample into groups to reduce variability. So blocking a group of people by age could be one of them. So it's very similar to your cluster sampling or your stratified sampling, but this is just, it's another form of doing that. Next we have confounding variables, which they look very similar to lurking variables, but then this is when an outcome is skewed because of an unknown variable, which could be lurking variable. But to be more precise, it is that when you have two variables in an experiment, there's a skewed outcome because of one of the variables that you're unsure about. Like, you're not sure about which one of the variables cause an effect. And this reduces variability and bias. So getting rid of confounding variables can help reduce variability and bias. Next one is matchpair, which is grouping participants on the basis of some variable. For example, same weight, height, race, etc. So as you can see, a lot of these pertain to stratified sampling and cluster sampling, which is very important. Biases are just a failure to represent the entire population. There are three key biases that you will have to know: non-response, response, and selection or undercoverage. So non-response or voluntary bias is when people are unwilling to respond to your survey. So for example, if you send out a survey, so say sending out a survey asking students for their GPA. Some students will feel very open about this question because they're not they don't want to cover up their GPA, and they're willing to tell people what it is. But other people are not. So it's when participants are only willing to send their or give a response to the question if they're comfortable with it. So sometimes you may not capture the whole population or your sample. The next one is response. It's basically when the wording of the question pushes people to choose a specific response. So for example, if your question was 95% of people who answered the survey said yes. So this would be an example, because you're pushing people to say yes, because now they know that 95% of people who answered the survey said yes. So if they said no, they'd be in the minority. The last one is selection or undercoverage. Is, for example, when you're trying to pick a sample, you choose only female students doing, let's say, maths as a degree. So you're not selecting as wide a spread of people as you can. Sometimes it does help if you're trying to determine an outcome of a very specific group. It's very important to know that non-response does not mean no response, and response does not mean they are responding. It's very easy to get these confused, so that's why I use voluntary and response as names for them. So talking about creating a simulation is very simple. There are 6 steps that are essential for any simulation. First, you have to describe your outcome. What is your positive outcome? What is your success? Like we talked about earlier, we need to describe what is our target value. Secondly, you need to assign a value to your outcome. For example, your outcome has to take on a numerical value for you to be able to do your simulation. Thirdly, you need to figure out how you're going to find your value. Generally, in questions, they will give you a random number table, or maybe you can use a random number generator. Next, you have to talk about how you're going to select numbers. So 2 digits at a time, row by row. For example, if it's in this case, I would use numbers 0 to 60, 0 to 60, and I would exclude 61 to 99. Since I'm using 2 digits at a time, it's important to do 0, 0. This would be incorrect. And I have to talk about a start and end point. When do I end my simulation and when do I start my simulation? Step 5 would be to begin your simulation. That's important because that's how you do your simulation. And step 6 would be to conclude. What did my simulation show and how? Look at this example. On average, suppose a baseball player hits a home run once in every 10 times at bat. This just means 10 times he bats, he'll hit a home run once. And suppose he gets exactly 2 chances to bat every game. Using a simulation, estimate the likelihood that the player will hit 2 home runs in a single game. Here is just a list of numbers that we would consider to be the random number table that every question should give you. If they don't, then you would have to find your random numbers, or there would be some way of assigning it. So above, as we talked about, it is creating a simulation. What are your steps? So I'm going to quickly copy these so that you can see it while we do the simulation. Maybe you'd like to try this out for yourself. Maybe not. That's completely up to you. So we have to describe our outcomes. What are our target values? So in this case, we're looking at estimating the likelihood that the player will hit 2 home runs in a single game. So what are my outcomes? Firstly, it's hitting a home run or not, with success being hitting 2 consecutive home runs. Now, this is very important because you're defining all the possible outcomes as well as what you're counting to be as a success. Secondly is assigning a value to your outcome. Now, this can come based off the question. The question says he hits a home run once every 10 games. That means he has a 10% chance of hitting a bat. To make it easy, I'm going to pick a very simple value that I'm going to say 1, or the probability or the assumption of hitting a home run is a value of 1. I chose single digits because there's a 10% chance of him hitting a home run, and using number 1 is a lot simpler. You could have picked a number like any number from 00 to 09 is a home run, or 00. However complicated you want this to be, you can make it, but make sure the number of digits line up. I'm just going to pick 1 is my home run. The next is choosing a method to find your value. In this case, they've given me my method, which is my random number table given in the question. You have to state where you got the table from. You can't just say random number table because that could mean anything. The next one would be choosing how to select numbers. So I'm going to select numbers one at a time, so single digits, left to right, and I will continue going and using numbers 0 to 9. In step 2, we could have also talked about what our target quantity is. Target is to get 2 consecutive ones. So basically you're looking at when is the first occurrence of 1. So now we're going to begin our simulation. For every time we get a home run, I'm going to underline it, and for every time we don't get a home run, I'm going to scratch it out. So first of all, we got a home run. Brilliant. The next two, because they're not a 1, it is not a home run. The next one, home run. Number 6, not a home run. 2, 3, 2, 5, 3, 6, 4, none. 9, 0, 3, 5, 2, not. None of these are home runs. Surprising, these numbers come up often. None of these are home runs. And now you see I get a 1 followed by another 1. So we also have to talk about when we end. Target, which just means endpoint, right? When is my endpoint? My endpoint is 2 consecutive 1s. So if I get 11 essentially, but you don't say 11, you say 2 consecutive 1s. So it's taken me this long to get 2 consecutive 1s. Now I stop my simulation, right? But during my steps I don't actually write begin simulation, but I will leave that in here. Now it's my time to conclude. So if we look at this, it's taken me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So it's taken me 22 games, or the player 22 games, to hit 2 consecutive home runs. So we're going to write it this way. Based on our simulation, it is predicted or estimated that on average it will take the player, I said 22 games to hit 2 consecutive home runs. I'll explain why we say what we do. Based on our simulation, we're not saying that this is fact. We're not saying that our simulation predicts how it will be, but it is from our simulation that we get these results. It is predicted or estimated that on average, because our simulation can differ vastly, so someone could have picked the number 7 and started at this line, picked the number 5, started from here, picked the number 2, started from here. They could have done anything. So it's predicted that from our simulation, on average, it will take the player 22, which is I think the value we got here, 5, yeah, 22 games to hit 2 consecutive home runs. So it takes whatever, then you put it in context. However many numbers and what you represented the number with, so the number of games to hit, and then 2 consecutive home runs, or 2 home runs in a single game. So I'll change that over here, 2 home runs in a single game. So that was how you make a simulation. Thank you so much for watching. That'll be at the end of this unit video. Hope you enjoyed.